Hello everyone, welcome back to another CSM video walkthrough. So today we'll be going over flatter me, which is an array problem. Before we jump into the actual problem, I want to give a brief overview on what arrays in Java look like and how to initialize them. It's a little bit different from Python, which is a little bit more straightforward, I'd say, but it's awesome because you can always know what type your array will contain in Java. So the first thing you should know is that when you initialize an array, you have to know the length of the array, and you also need to know the type of the object that or primitive type that will be inside the array. So here we can see an integer array A. So here on the left side, we are specifying that the array is of type integer. And on the right hand side, we are saying is equal to new. This new keyword is super important when creating a new array in Java. You always need to have that on the right hand side if we are creating initializing an empty array. And this number 3 says that the length of the array is of size 3. So when I execute this line, what it's doing is it's creating an integer array A, which is pointing to just like an empty array. So these are all null values of size 3. And you know that each one has to contain an integer. But when you initialize it, it's all null for now. It is also possible to initialize and fill the array in a single expression. So here we can see that it's all null because we only initialize it, but we didn't actually fill the array with any contents. But if you want to do that all in one line, we can have a B array. So this is pointing to, you know that these 3 boxes have to be of type integer, right? Because we specify that here and here. But we also know the values. So inside these curly brackets are the values inside the array. So 1, 2, and 3. So we can do that all in one time. And the third way we can do this is Java is actually pretty smart. So it can infer the type of array from context. And so you still do need to specify the type on the left-hand side of the expression. So you know that's an integer array C. But on the right-hand side, you don't actually have to put this new int part. You can just specify, like if you know that you want to have your array contain 1, 2, and 3 to start with, you can just have the curly brackets with 1, 2, 3. So this will actually result in the exact same array, 1, 2, 3. So I know this can be a lot to take in, especially as for someone who's new to Java. There's a lot of different ways to initialize arrays. The best way I would tackle this is by honestly writing this down somewhere or kind of memorizing the different ways you can initialize an array. And as you use more, you'll kind of find a way that you prefer, or you'll be able to initialize it a different way depending on what the problem is asking you to do. And as you get used to it, it'll definitely become easier. But for now, I would recommend writing down all the different ways you can initialize an array. And that way, based on the problem specifications, you'll know which is the best way to use. And so uninitialized values have a default value like 0, false, or null. And so let's say you have a string array C. So C is now no longer pointing to this. You want it to point to a array of length 1, right? Because it specifies 1 there, and the type is string. Well, C of 0, uninitialized values, it'll automatically be null, but you can also explicitly say like C check that by saying C of 0. So this is the 0th index of this list or array C. We can check that by saying it's equal to null, which it is because it's uninitialized. So that's one thing to note. You might get a lot of null pointer exceptions if in your code you're creating a lot of you just initialize the array, but you don't initialize its value. The value will default be set to null. And so if you then try to work with this array, you'll probably run into null pointer exceptions if you're trying to do something with a null value that you can't actually do. So I'd make sure in your code to always, like if you need to initialize the values, make sure that you're doing that step. Otherwise, you're going to run into issues. Okay, so that was a lot of background for arrays. Let's jump into this problem, which is actually called flatter me. And so the first step is to implement middle, which takes in an integer array and returns the middle element. And if no element is in the exact middle, we want to return the element to the left middle. So an example of this, let's say we have an array of size 3. This is pretty simple, right? The middle element is 2. That's the exact middle, and there are no kind of questions about that. But let's say you have 4 elements in your array, 1, 2, 3, 4. it says to return the element to the left middle. So that means I'd want to return 2 and not 3, since there are technically 2 values in the middle. Awesome. So the way we can do this is by basically determining what index the middle is at. So here we can just return in one line. Let's say we have, so our array is actually named data. So in order to get the actual value at the middle, we have to do data of something. So data of 0 would let's say this is data. Data of 0 would be 1, right? Because this is a 0th index, first index, second index, and third index. And so that's kind of how you access an element in an array. So we want to actually access the middle element in the array. So the way we can do that is by finding the complete length of the data array, subtracting 1 and dividing it by 2. So the reason why we are dividing by 2 is to find the middle. So let's say you have, like, this is data, right? In the first example, data, let's call this data 1. So data 1 dot length is equal to 3, right? Because there are 3 boxes in our array. And so if we were to divide this by 2, is going to be equal to 1.5, but in Java, since we are just using like standard division, it's going to cut off any extra decimal. So it's just going to give you 1, and that's going to be your middle element, right? But let's say for 4, the value, so that's correct, because you want your index, so 0, 1, 2, data length divided by 2 is equal to 1. What is the element at the first index? Well, the element at the first index is 2, which is the middle element. So this is what we expect. But this is going to vary a little bit, right, for the 4 element array. So let's say we call this data 2 dot length by 2 is going to be equal to 4 divided by 2, which is equal to 2. And so that's actually this element, and that's the right middle. That's not the left middle. We want the left middle. So the way we're going to fix that is by subtracting 1. So data 2 dot length minus 1 divided by 2. Now that would be 3 divided by 2, which is actually equal to 1, right? Because we cut off the extra 0.5 decimal when we divide in Java. And so that is going to actually be the correct value. Let's see if I can erase yeah, perfect. It's going to be this. And you'll notice, you might be asking, what about the previous instance, right? Will that affect anything? Well, if our length is 3 and we subtract 1, that's going to be equal to 2, right? And 2 divided by 2 is still equal to 1. So it won't affect the previous case where we already have a perfect middle. So that's why we're going to return data of data.length minus 1. We're going to divide that by 2. And that's our final answer for middle. Perfect. So now let's move on to the second part, which is our method flatten. Before we do that, I'm going to erase everything I currently have, so I have room. Okay. Cool. So in flatten, what we want to do is take in a 2-dimensional array data and return a 1-dimensional array that contains all of the arrays in data concatenated together. So an example, a 2-dimensional array kind of looks like a matrix, if you've seen that before. So a 2-dimensional array would look something like this, where we have, let's say we have 3 elements in the original one. These are all going to point to other arrays, right? So this is 2-dimensional because the array points to another array. And so if you were to kind of look at this in like a mathematical view, it would look like a matrix where, like, let's say you have 1, 2, 3, 6, 7, 8, 9. It would look like this. So you have kind of like your rows and your columns. So flatten basically wants to take this 2-dimensional array and return all of this concatenated together. So this would, it kind of wants you to take this form and make it equal to just one long array. like this. And that's the background for the question. So now let's actually kind of think about the code. So what are the steps we need to do in order to make this one-dimensional array? Well, first, we need to make sure that we're allocating the correct length for this long one-dimensional array, right? Because in Java, if we recall, back up to here, arrays are ordered sequences of fixed length. So we always need to know the length when we create an array. So in order to create the array that we're going to return, we need to know exactly how many elements are going to be in it. So what we can do to do that is first set our size, a size value equal to 0. And then we want to iterate basically over every single row in our array as specified here. So we want to iterate over each of these rows, figure out each one's length. So here in this example I drew out, each of those rows have a length of 3. And so if we add all of those together, we know that our final array has to have a length of 3 times 3, which is 9. But in this instance, we don't know the length of every single row in the data array. So we need to actually compute that. So we can do a for loop to do that. So for int array row. So we're actually only going to look at one row. So this is basically, let's say we're looking at the 0th row. We're only going to look at these values here. And then for the first row, you only look at 4, 5, 6. And then for the second row, and so on. So for int row in data, and this whole thing is data, by the way. Data points to this, which point, and each of those point there. We want to basically increase our size. So size plus equals row dot length. So hopefully that made sense, because now we just basically created an empty array. So for that example I drew out, we basically created this empty array of length 9. So, oh no, I don't think I'll be able to fit everything in here. Then, okay, let me make this a little smaller. Okay. Now hopefully everything will fit. 6, 7, okay, 8, 9. Cool. So now what you can do is, after we allocate space, we can then proceed to fill in these empty boxes, because these are all initialized to null at first, right? Because what we talked about earlier with like making sure to initialize the values. So first, let's actually create the result array. So int array result is equal to new int array of size, right? Size should be size. So we said, like for this instance, size would be equal to 9 by the time you get to this line. And now you're going to be initializing this new result array right here of size 9. Cool. So now the next step is to actually populate those values. So if we create a variable I, which is equal to 0, let's iterate over every single row in the data array, or in the data 2-dimensional array. So for int array row in data, we're doing this again. We basically want to set result of I. Oh, I actually missed a step, sorry. So first we're iterating over every row. So that is like this row, this row, this row. And then we want to actually go into every row and look at the values in each row. So like this, this, and this. So we actually need to have a nested for loop. So we have another set of values to look through. So for int value in each row. These brackets. Sorry if the brackets don't line up as well. I'm writing kind of big, so I didn't fit it into the space. Result of I is equal to value. And then we can do I plus plus. So essentially what we're doing here is first we set I equal to 0 outside, right? So for the value, for every value in the row, so first we are at the 0th row, we look at the 0th value. So that's 1. So now we're going to set the 0th value in our long one-dimensional array to be 1. So this is basically going to be set to 1. And then we increment I, so now I is equal to 1, right? So then we can look at the first index in our first row here, which is 2, and the next one will be set to 2. So we would set the first index to 2, and then so on. So that would be finished for the first row, right? So this would be set to 3, because we'd increment I again. And then after we finish with this row, we're going to go back to the outer for loop and go to the next row in the data and basically go here and then increment over 4, 5, and 6. And so that's basically, and then, but for 4, 5, and 6, the I will be incrementing constantly. So instead of being 1, 2, and 3 again, we're going to set it to I is equal to 4, or in this case, I is equal to 3 because we're 0 indexing. So 1, 2, 3, so 0, 1, 2. So at the third index, we're going to insert 4. So the reason why we're doing this is because we're basically changing this 2-dimensional array of data into 1-dimensional. And then at the very end, we're just going to return our result. Return. And that's the end of our function. So hopefully that made sense. If it didn't, no worries. It is a pretty complicated function, so definitely reach out to your CSM mentor for more help. But in the meantime, good luck. And yeah, that's all for this walkthrough.